today is curve fitting with quadratic models. And the first thing we're going to do today is we're going to look at some tables, and we're going to determine if a function is quadratic from those tables. Like I said earlier, this packet we're going to do in 2 days. So I'm going to skip around in this packet a little bit because I decided I wanted to break it up a little bit differently. So tomorrow we're going to go over how to solve systems and create quadratic models using elimination. You did a little bit of solving systems in Algebra 1, and that's actually a concept that comes back on the PSAT and SAT. So some of you might have taken that last week, some of you are going to be taking it in the spring, so I want to make sure that we hit on those concepts again. But the first thing we're going to do is look at quadratic data. So we did something similar when we were looking at linear models, but with a quadratic model, there are a few things we have to look for. Every quadratic function is going to have what's called constant, non-zero, second differences. Constant, non-zero, second differences. Okay, so those are key terms that you're going to be putting in your explanation. And you can see I just made a few notations underneath. So if a number is constant, what does it do? Yeah, stays the same. So the number is going to stay the same. If it's non-zero, that simply means it's not zero. Okay, so it just can't be nothing. And then the second is going to be the second difference, so we're going to do it twice. And then the last thing is the difference itself, which is going to be the result of subtraction. Okay? All right, so for example 1, let's first just highlight what they are asking us to do. So it says determine whether each data set could represent a quadratic function, and then explain why or why not. So determine whether it could represent a quadratic function, and then the explain why or why not, that's something that we'll definitely work on together. Okay, so when you are finding the differences here, you also have to make sure that the x values are equally spaced, and that's usually what I do first. So if they're equally spaced, it's going to be the same number between each one. So like to go from 1 to 3, I would add 2, right? So this would be plus 2. To go from 3 to 5, I would add 2. To go from 5 to 7, I would add 2. To go from 7 to 9, I would add 2. So the first thing I always start off with is I ask myself, okay, are these equally spaced? Okay, so equally spaced x values. Do I have them? Yes, I do. Okay, so equally spaced x values, yes. So now I can start the process to finding the differences. Okay, now it's called the differences because you can subtract, but I think a lot of us are going to be more comfortable asking ourselves the question, what do we add to get to the next number? Okay, so to calculate the first differences, I'm just going to put first diff. Okay, you can ask yourself, what would I add to -1 to get to 1? We usually use these little carets here. So what would I add to -1 to get to 1? 2. You could also subtract. You just take the second one and subtract this. 1 minus -1 is really 1 plus 1. We get from 1 to 7. You would add how many? Yeah. Or 7 minus 1 would be 6. 7 plus 10 would be 17. 17 plus what would be 31? 14. Nice work. Okay, so questions on how I found the first differences? You guys ready to find the second? Alright, so second second differences, you're going to do the same thing. It's just between these two guys now. So again, you can either think, oh, 6 minus 2 is 4, or you can think, what do I add to 2 to get to 6 plus 4? The reason why I put the plus is because sometimes you could be going down, and if you're going down, you would use minus, okay? From 6 to 10, it is 4. From 4 to 14, yay, what do we got here? Yeah, those are constant, right? So again, we're just going to go through that checklist, and the reason why is because that's what we're going to be including in our solution. So are these numbers constant, which just means are they the same? Yes, so let's put a check. Are they non-zero? Yeah, 4 is not 0, correct? Yeah, because technically if this was 0, then what would be the same? The first ones, right? So that's why it can't be 0. And then, are they the second differences? Why, yes, they are. Okay, and then we already said, are the x values evenly spaced? So when we're writing our explanation, we want to make sure we're answering the question. The question is determining whether it could represent a quadratic function. So is this a yes or a no situation? Yes. Okay, so we're going to say yes. The data represents a quadratic function, and it asks us to explain why. So yes, the data represents a quadratic function, so we're going to say because. And then we're going to include all those key terms that I had you write in above, those 4 key terms, the constant, non-zero, second differences, we're going to include that. And that's because the second differences are constant and non-zero for equally spaced x values. Okay, so yes, the data represents a quadratic function because second differences are constant and non-zero for equally spaced x values. Okay, so again, we just have those key terms in there, right? It's the second differences. They are constant, they are non-zero, and we have equally spaced x values. So those are key terms that I'll be looking for, okay, when you're writing your explanation. Okay, so I want you guys to do part B. Let's see how we did. Okay, so Julian, what did you check first? Okay, good. So were the x values equally spaced? Yes. Okay, so equally spaced x values. Nice. And then notice these were equally spaced by 2. These are equally spaced by 1 each time, and that's fine. Okay, awesome. All right, and then Dylan, what did you do after that?
I found the differences between the y values.
Okay, so can you tell me what the first differences are?
I get +2, +6, then +18, then +54.
Nice. Okay. And I like that he said the plus was it too, because remember, sometimes you might be going down, and if you're going down, you have to have the minus. Okay? Okay, and then Ashay, what did you do after that?
I found the second pair.
Okay, what were those?
4, 12, and 36.
Good. All right, so what are we thinking? 4, 12, 36. If it's quadratic, what do these have to be? They have to be constant. So are they constant? Nope. Okay, so since they are not constant, again, we want to make sure that we are addressing the question. So could it represent a quadratic function? No. This data does not represent a quadratic function. I'm fine if you abbreviate here. You can put quad function. But then you have to explain why. I'm even okay with this if you want to put because. Okay, so because the second differences are not constant, for equally spaced x values. Okay, so if you need to add a little something into your explanation to make it more thorough, go ahead and do that now. Remember, this is your model for how you want to do your homework, and that's really going to help you prepare, okay, for your assessment. Any questions for me on part 1? Okay, so the next thing we're going to do is we're going to practice writing a quadratic function. All you need to write a quadratic function are 3 points. That's all you need. If you're given 3 points, you can either write the quadratic function by hand, or you can use your graphing calculator. Okay, you will need to know how to do both. So today we're going to focus on the graphing calculator part, the by hand. This is going to be day 2. Okay, so I'm just going to put day 2 here. So this is what we're going to do tomorrow. So we are going to skip over the second page, and we are going to go to example 3 on the 3rd page. And I'm just going to put, this is day 1 here. Okay, so for example 3, it says write a quadratic function that fits the given points using a graphing calculator. Okay, so you do need your graphing calculator. Okay, and then I'm going to go through the steps with you, and then we're going to do them together. So sometimes when there's like a button to push, I'll circle that in a special way. What we're going to do is we're going to use the stat feature. We're going to enter in x coordinates into list 1. We're going to enter the y coordinates into list 2. So this is something that we did before when we were doing linear regression. So we have the x coordinates in list 1. We're going to have the y's in list 2. Okay, we'll go back to the stat feature. We will use our arrow to go over to calc, and we'll select 5, which is the quadratic. That stands for quadratic regression. Now, depending on what model your graphing calculator is, there's a couple different things you might need to do. You might have to select calculate, or you might have to press the enter button twice. So you can select which is going to be correct for your calculator. And then what this does is it generates your values for A, B, and C, which is honestly really nice. So you're going to find the values for A, B, and C. Sometimes they're going to be whole numbers. Other times they're going to be decimals. If it is a decimal, then we have to round to the nearest hundredth. How many places after the decimal is that? 2. Okay, so if it's a decimal that you have to round, 2 places after the decimal. If it's just an even decimal that's 1 place, then you're fine. Okay, and then you have to write your answer in the form. It's standard form. Do you guys remember standard form? Starts with f of x equals, and then what? ax squared plus bx. Nice job. Okay, so you just have to make sure you have your f of x, okay? All right, so let's do part A together. Got your calculators ready? And then if any of you need a graphing calculator, just trade me your device. Now let me borrow one. Same way you trade. I just want to make sure you all have your graphing calculator. Okay, so go ahead and go to stat. So follow the first couple steps there. Alright, so stat, how did you guys do? Did you guys do the first step? Okay, so you go to stat, and then you just press enter. This is where you enter your L1 and L2. Now I said to enter the x coordinates in list 1. So if I'm entering the x coordinates in list 1, okay, Cooper, what are my x coordinates for part A? Yeah? Nice. Okay, so that's what we're going to do. -4, -2, and 2. Okay, that's going to be my L1. Okay, and then, Gwen, what am I going to put in my L2? Good. And you guys do have to enter them in that order, because what's happening is you are entering in the points. Okay, just like we did with the LinReg. It's the same type of process where you're telling your calculator the correlation between these points. Okay, so you have your L1 and your L2. So your X's and then your Y's. Any questions for me on that part? All right, ready for the next? Okay, let's do it. So go to Stat. We're going to use the arrow key to go over to Calc. And then you can either arrow down to 5 and press Enter, or you can just press 5. So last time we were using LinReg, now we're using QuadReg. And then depending on what calculator you have, you might have to arrow down to the calculate. It might take you to like a screen and you might have to press enter. It just depends. Okay, but you should get to a screen where it's A, B, and C. You guys got there? Give me a thumbs up when you got this. Okay. All right, great. So then once you have it, now we're going to write our function. So A was 0.5 or 1/2, B is -3, C is -8, and then your final answer would be f of x equals 1/2 x squared minus 3x minus 8, and that is your final solution. Okay, and then will you do part B for me? And then do you guys remember how to clear your list? You can press clear, enter, if you highlight L1. Okay, so if you go to STAP, enter, you want to clear it out, just clear, enter, and then they go. Clear, enter, then they go. Okay? So now you can enter those in. Okay, so for B, Maya, what'd you get for the value of A? Oh, okay, go ahead. Good, okay, so your A value is 3. And then, Luke, what'd you get for B? Good. Oh, I like that. 4/5. Seth, what'd you get for C? Good. Okay, so then your function, your f of x, make sure again that you have f of x equals. So it needs to be in this notation. Plus 0.8x plus 0.4. And if you have the 0 in front, perfectly fine. Okay? Alright, so we give you time to work on your homework today, so you do need to do that. And while you guys are working on your homework, I am going to call you up if there's like things that are missing or if I have some questions for you.